Hello, Accelerated Math 7-8 students. We are working in Module 14, and this is Lesson 16. Okay, so the name of this lesson is, let me get it to focus in on what we're doing. It's called the computation of the slope of a non-vertical line. Okay, and in yesterday's lesson we learned that vertical lines have undefined slope. I want you to keep that in mind when we're talking today. So our goal, today we will learn how to find slope when the graph has not been drawn. So we're going to look at information without a graph, right, to figure out what the slope would be. Sorry, I'm trying to get the size better. Okay, question. What is the easiest and most efficient way to determine the rate of change of a line? Remember, rate of change is another name for slope. Another name for slope is unit rate. Another name for slope is the m. I'm trying to say all of them because the more you hear them, the more you will recognize them. All right, things to remember. The first thing that I want you to do, and in our goal, it says that we don't have this, but I want to see if you can tell me what the slope of the line is from the graph, because I know we've done it in the past, but I want to make sure everybody's clear on how to do that. So the thing that I want you to think about is you need to look at the graph to see if you can figure out how it's changing. And one thing that you have to keep in mind when you're looking at the graph to see how things are changing is you want to try to find a spot on the graph where the line crosses specific points. Okay, and I'm trying to make this graph really big so that you can see the actual points. So here is the graph that we have, and I am going to put a dot every time I see it on a specific point, not a point and a half or a point and 3/4, a specific point. And so I see a spot right there that has a specific point. Okay, I see another spot right there that has a specific point. I see another spot right here that has a specific point. I see another one here that has a specific point. I see another one here that has a specific point. And I see another one here that has a specific point. And then this one looks like it's a specific point right here where it falls off. Okay, so by looking at where we put those specific points, could you tell me, just by looking at the graph, what the slope of this line is? Because that's the question, is can you determine the slope of a graph? Okay, and the reason I want to know is, can you do that, first of all? But then our goal is, how do you find slope when the graph isn't drawn? So looking at this, remembering that slope also, hold on, I want to use a pen because you can see it better. Slope is determined by how much it rises divided by how much it runs. And we've been doing this every day for the last couple of days. So the reason why I had you find those specific points is now we can talk about how much it rises as opposed to how much it runs. So this one looks like it goes up 1 over 3, 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 up 1 over 3. So my question to you is, according to the graph, what is the slope of this graph? And hopefully you guys all heard me. What did we say we were doing? Up 1 to the right 3. So our slope would be what? 1/3. Okay, does everybody see how we did that? Now sometimes on a graph, you're not going to be able to find clearly defined points that easily because they won't be there. They'll just be 2 points, and you're going to have to figure them out. We'll get to that in just a minute. So I want you to be thinking of that. Before we do that, however, our goal said that we were going to find the slope of a line without the graph. What form is this, for those of you who remember? If you said standard form, you're right. So right now, this equation is written in standard form. Is there a way that we could transform this equation into another equation that tells us automatically what the slope is? Okay, and if you're saying yes, 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 then you are correct. And the way that you are correct is we need to turn it into slope, intercept, form.
This is just a reminder that there is a 8th grade boys basketball meeting in room 301. If you are
here we go. We're going to do this quickly because we're running out of time. So we have to get the x on the other side. So we're left with 2y equals negative 6x plus 12. Then we have to get the y by itself, so we divide everything by 2. So 2 divided by 2 is 1. 1 times y is y. Negative 6 divided by 2 is negative 3x plus 12 divided by 2 is 6. Did we now, that we have it in slope-intercept form, find the slope? What does the slope equal? If you said negative 3, you are correct. Okay? So, if you have a standard equation, turn it into slope-intercept form, and then you easily can find the slope. Sometimes we must be able to find the slope without graphing, which is what we just did. Use the ordered pairs of 2 points that sit on the line, label the point 0.1 and the point 0.2, and then compare the difference between the y values and the differences between the x values. So what this is saying is pick 2 points on the graph. So let's go back to the graph for a minute. I'm going to pick this point and I'm going to pick this point. Okay? So we're labeling this point 1 and we're going to label this one point 2. Okay? What is the ordered pair of this one? So that's negative 2. So that would be negative 3. So we're going to say we went negative 3, and then we went, if this is negative 2 down here, then that must be negative 1. So point 1 is negative 3 comma 1. Point 2 is 3 comma 1. Okay, so that wasn't so hard. So now it says compare the difference between the y values. So you're going to take y1, and this is x1, because that's point 1. This is y2, and this is x2, because that's point 2, and you're going to find the differences. So you take y2 minus y1 divided by x2 minus x1, because you have to find the differences between the y values and the differences between the x values. Okay, so now I should move it so you can see it. We take the y2, which we identified as 1, and the y1, which we identified as a negative 1, and we subtract them. So minus y1 divided by 3 is x2 minus x1, which is negative 3. And now this is coming back to our long journey of figuring out how to subtract negatives. Remember, subtraction is the same as adding the opposite. So we have 1 plus the opposite of 1 is 1. 3 plus the opposite of 3 is 3. Negative 3 is 3. So now we have 2/3. So the slope on that one is going to be 2/3. And if you look at it, that's exactly what happens. Let's see what happens. We go up 2. So I'm going to use the pen actually. So we go up 2, which we did, and we go over 3 full pieces. So count them. So that would be, if we're right here, 1, 2, 3. Okay? Oh, I'm sorry, that's not 3, that's 6. Mrs. Nelson, come on, get it right. 3 plus 3 is 6. So we are correct. So it would be up 2 over 6 if you count them. And what does 2/6 simplify to? 2/6 simplifies to 1/3. So is our slope 1/3? The answer is yes. Okay, so if you're overwhelmed by this, I'll spend some more time in class helping you with it because we've run out of time. Let's go back to our goal for today. Our goal for today is, today we will learn how to find slope when a graph has not been drawn, which we did. We've done several different ways, and I will bolster the last one when we get back in class. What is the easiest and most effective way to determine the rate of change of a line? For me, it is using slope-intercept form. If you want to just look at it, you can do that. Or if you want to use this formula, you can do y2 minus y1 divided by x2 minus x1. And we'll talk about that some more in class. All right, kiddos, that's all I have for you in this lesson today. Have a good one. See you later. Bye.